In section 1.3, we're going to look at solving some equations, and we're going to take this step by step. So in this first section, we're going to look at solving one-step equations that just involve addition and subtraction. So this goes with our big learning goal of understanding how to solve linear equations, and this is going to expand over several lessons. Okay? So remember, we know the difference between an equation and an expression, right? An expression is just made up of constants, variables, and operations. So we might have the expression 3x plus 2. Now that's different than an equation, which has to have an equal sign in it. So maybe we have 4 equals 3x plus 2. And that would be the difference between an equation and an expression. So an expression is not something that we can solve. An expression is only something that we can evaluate. I could plug in different values for x and get out different values for the expression. However, an equation is something that we can actually solve. There is only one value of x that I can plug in here to make the left side, 4, equal to the right side, 3x plus 2. Alright, so how do we tell if an equation is in fact a linear equation? So there's all sorts of different types of equations that we're going to learn how to solve, but how do we know if it's what we call a linear equation? And we talked about this word that we see in there, the word line, but what does that have to do with the linear equation? Well, we're going to explore the line aspect of it in one of the later units that we're going to talk about when we talk about graphing. But in this case, we're not going to really see the line part of it so much. So how do we tell? Well, a linear equation is one where the variable that we see, or sometimes there's more than one variable, but that variable is raised to the first power. Okay, so remember, when you see just x by itself, that's really x being raised to the first power. We never ever write the exponent, but it's really there. It's really what it means. It's really x to the first power. So an example of a linear equation would be 3x plus 4 equals 9. We have the one variable. It's getting raised to the first power. There's nothing else in there except for that variable being raised to the first power. Okay, we've got constants, operations, variables. We have our equal sign, which tells us it's an equation. So we're good to go. So now let's practice identifying which equations are linear and which equations are not linear. Okay? So in the first one, we have 9x minus 1 equals 10. So we look at the variable. There's only one variable. It's x. It's getting raised to the first power. So yes, this guy is a linear equation. In the second equation, we have 5 minus 2y equals 7. So my variable is y. It is getting raised to the first power. There's no other variables, no other exponents, so this is also linear. It doesn't matter that it's a different variable. Doesn't matter that a constant came first. This guy's still linear. In the next example, we have x squared plus 2x equals 0. So here we have an x to the first power in the 2x term, but unfortunately in the first term we have x to the second power, right? So this guy is not linear. We have our variable that's being raised to a different power other than 1. If we go down, if we have x over 3 equals negative 4, or in other words, x divided by 3 equals negative 4, this one's a little tricky because we have division involved, right? But the x in the numerator is being raised to the first power. And another way that we could write this equation is as 1/3 times x equals negative 4. And that makes it look a little bit more like some of the other equations that we've seen. And this one is also linear. Now this is different from the next example. In the next example we have 5 divided by x plus 1. So even though x is being raised to the first power, since it's in the denominator, this makes this a non-linear equation. We haven't talked about these exponent rules, but if we have an x in the denominator, if we wanted to write it in the numerator, it would be the -1 power. So an easy way to just remember this is you can't have any variables in your denominator and have it be a linear equation. So this is an example of something that's not linear. All right, so now I want to talk about inverse operations. And this isn't a technical definition, but it's a really handy working definition. We say that inverse operations undo each other. So we say addition and subtraction are inverse operations because addition undoes subtraction and subtraction undoes addition. So let's look at a couple examples here. I just have expressions, not equations, but I want to think about isolating or getting x all by itself. Remember, isolate means get by itself. So if I see addition, like I do here, I can undo that addition with subtraction. So if I had the expression x plus 3, and then I subtracted 3, well, we know that 3 minus 3 is 0. So now this expression becomes x plus 0, and that, of course, is equal to just x. So we're undoing the operation of addition by subtracting. Here in the next example, we have x minus 6. So if we do the same thing, since we see subtraction, we're going to undo that subtraction with addition. Then I can combine like terms to put my constants together. -6 plus 6 is 0. So we have x plus 0, and that simplifies to just x. Now I just want to remind you, these are not equations that I'm solving here. I'm just kind of highlighting the idea of what addition and subtraction do as inverse operations of one another and how they undo each other. So we're not solving here, we're just showing how things undo each other. Let's look at multiplication and division. They're also inverse operations. So here we have multiplication 2 times x. So if I wanted to undo that multiplication, I would divide by 2. And then I can think, well, 2 divided by 2 is 1. So if I simplify this, we'd have just 1x. Here where I have x over 5, or x divided by 5, I could undo that division by multiplying. The reason this works is because I can multiply and divide. Really, if I'm just multiplying and dividing, I can do it in any order I want to. So I can think about this as 5x over 5, and then what I'm going to do is simplify the division, right? 5 divided by 5 is 1, so this is equivalent to 1x, or just x. So we need to know how to work with these inverse operations, so when we want to solve our equation, we can get whatever our variable is all by itself. That's our goal. We want to know what x equals. We want to know what it equals. We got to get it by itself in the equation. Okay, so now let's do some examples. Let's focus, like I said, in this section on just solving equations with addition and subtraction. Now, this is a really huge key idea here. If you have an equation, two things that are equal to one another, then we can add or we can subtract the same amount to both sides of the equation and the expressions will stay equal. Right? Think about a scale and think about balance. If I add the same weight to both sides of the scale, it stays balanced. If I take away the same weight from both sides of the scale, it stays balanced. So as long as I do the same thing to both sides of the equation, we preserve the balance, and so it stays equal. I like to say we preserve the equality as long as I do the same thing to both sides. So let's look at this example. We're going to solve the equation x minus 4 equals 5. So I want you to write these steps over on the right-hand side when you're doing your notes, and I want to use these as a guide, especially if you haven't done a lot of work with solving equations before. But this isn't optional. I want you to write all of these steps and then follow through as we go. So make sure when you're writing the steps, it's right next to the work that you're doing for each step. Okay? So step 1, write the original equation. Okay? When you're doing your homework, write the original equation in your notebook so we can solve it. Now, when we look here, we can see, oh, the operation that I see is subtraction. So how do we undo subtraction? We undo subtraction with addition. So what we're going to do, I'm going to rewrite the left side, and I'm going to rewrite the right side. And I'm going to undo that subtraction with addition. Since I was subtracting 4, I'm going to add 4 to both sides of the equation, right? As long as I add the same amount, it stays balanced. Now we want to simplify both sides of the equation. So here, combining like terms, negative 4 plus 4 is 0. So this is x plus 0. Here, 5 plus 4 is 9. And x plus 0 is x, so we arrive at the solution, x equals 9. Now this would be our answer, or the solution to the equation. Now here's the next part. You've got to check to make sure that your answer is really a solution. So in order to check, write the original equation. The original equation was x minus 4 equals 5. Plug in our value for x. Our value for x was 9. So I plug that in, and we're going to check to see if that's solution. If it's a solution, the left side of the equation will equal the right side. So 9 minus 4 is 5. 5 equals 5. Check. We know that x equals 9 is a solution to our equation. Alright, so notice what I did up here is when I solved my equation, I added 4 to the left and I added 4 to the right, and I wrote it horizontally. In the next example, I'm going to write that vertically, because that's generally what we tend to do when we're solving equations. It's usually easier to work vertically. So I'll show you that way, and we'll talk about which way you like better in class. Okay, so now let's solve the equation x plus 2 equals negative 4. So again, we're going to write the original equation. We've got that here, x plus 2 equals negative 4. I can see that the operation is addition. So subtraction undoes addition. So we're going to undo the addition by subtracting 2 from both sides of the equation. So here's my equal sign. I want to make sure I do it to both sides. And I'm going to work vertically this time. I'm going to subtract 2 from the left and subtract 2 from the right. So now when I simplify both sides, I don't have anything to subtract from the x, so I'll still have x. 2 minus 2 is 0, and negative 4 minus 2, remember that's like saying negative 4 plus negative 2. My numbers have the same sign, so I add them, and I keep the sign, so that would be negative 6. So x plus 0 equals negative 6, or x equals negative 6. Okay, we're not done. We've got to check it. So we start by writing the original equation. X plus 2 equals negative 4. I plug in my value for x. My value was negative 6. And then I rewrite the rest of the equation. So negative 6 plus 2 equals negative 4. And then we simplify. Negative 6 plus 2, opposite sign, so I subtract. 6 minus 2 is 4. I keep the sign of the larger number, which is 6. So negative 4 equals negative 4. We did it right. We know that x equals negative 6 is a solution to our equation. Perfect. Alright, so now let's just do a couple more examples of one where you have to undo addition and undo subtraction again. Over here, we see subtraction, so we're going to undo it with addition. Make sure you do it to both sides of the equation. I like to sometimes draw a vertical line through my equation because that makes sure that I'm doing the same thing to both sides and not accidentally doing the same thing to one side of the equation but doing it twice. We see that sometimes when our equations get more complicated. So we'll add 1 to both sides. So this gives me x plus 0 because negative 1 plus 1 is 0. And on the right, negative 8 plus 1 is negative 7. So that means x is equal to negative 7. Now we're going to check it. So to check it, we write our equation. x minus 1 equals negative 8. Plug in our value. X was negative 7. Negative 7 minus 1 equals not negative 18. Whoopsies. Hello. Sorry. Negative 8. Simplify. Negative 7 minus 1 is negative 8. Negative 8 equals negative 8. Check. We solved it right. All right, let's do the one on the right. Here we see our operation is addition. So we're going to undo that with subtraction. Subtract from both sides. So we have x plus 0 equals 5 minus 6, which is negative 1, or x equals negative 1. So that's my solution. Now I'm going to check it. X plus 6 equals 5. I'm going to plug in x equals negative 1. So we have negative 1 plus 6 equals 5. Negative 1 plus 6 is 5. 5 equals 5. Check, we have a correct solution. Perfect. All right. So now I want to talk about some more complex equations. Still one step, in that we're only undoing one thing at a time. We're either going to undo addition or undo subtraction. But sometimes we're going to need to simplify our equation before we can solve it. So here's a really good example. We've got x minus negative 4 equals 7. So we see subtraction in the problem, but in this case it might help to rewrite this subtraction as addition. So remember, to rewrite subtraction as addition, we add the opposite. So the opposite of negative 4 is positive 4, right? The other way to think about this is two negatives right next to each other make a positive. By the way, these parentheses aren't doing anything except for making sure that I understand that 4 is negative. So this is like writing x minus negative 4, and two negatives together make a positive, so this is like x plus 4 equals 7. So now we can see that my equation is really an addition equation. To undo that addition, I'm going to subtract. Since I was adding 4, I'm going to subtract 4 from both sides. So now I'll have x plus 0 equals 7 minus 4 is 3, or x equals 3. Plug it back in to check our work. My original equation was x minus negative 4, so I'm going to plug in my 3. X was 3, and we want to make sure that 3 minus negative 4 equals 7, and again this turns into 3 plus positive 4. 3 plus 4 is 7. 7 equals 7, so we have a check. We know we did our work correctly. Sometimes you'll see an equation like this, and I think, especially when we're beginning, it can be nice to write the variable first in the equation, because that really highlights the operation that's being done to the constant, and that really tells you what to undo it with. So in this example, the 9 is positive, right? And we're adding that to x. So since we're adding, we can rearrange the terms. We can rewrite this as x plus 9 equals 14. So that makes it really clear that the operation that's being done to the 9 is addition, and I'm going to undo that with subtraction. So subtracting 9 from both sides, 14 minus 9 is 5, so we get x equals 5. Then if we plugged it back in, 9 plus 5 equals 14, 9 and 5 is 14, okay, so we're good, right? So where this becomes really beneficial, let me just come up with another example over here, is when you have like some negatives and stuff thrown in. So like, let's say our equation was negative 7 plus x equals 2, right? So we still have addition, so we can rearrange the terms, but if we rearrange the terms, the x was positive, and we were adding to that negative 7, right? So if we have x plus negative 7, that's the same as saying x minus 7, and then we can say, oh, well, yeah, this equation really had addition in it originally, but if I rearrange it with the variable first, I can see that, oh yeah, this is really a subtraction equation, and so to undo that, I would add 7 to both sides. So negative 7 plus 7 is 0. So all that's left on the left is x. 2 plus 7 is 9. So my solution to this would be 9 if I plugged it in. Negative 7 plus 9 equals 2. Negative 7 plus 9 is 2. 2 equals 2. So we have a check. Does that make sense? So try to rearrange your terms with the variable first, paying attention to the sign that goes with the other number. Make sure that stays with it, so we can rewrite our equation as either an addition equation or subtraction equation and identify what variable or what operation it is that we need to undo. Okay, so that's it. You know the deal. Give me questions on the left. 2 to 4 sentences here. Really focused on inverse operations, undoing addition and subtraction, and the steps to solving your equations.